is planets, stars, natural satellites, and plasmas.
Plasmas?
Plasmas, yes. And
what are those?
would anyone know why did he highlighted plasma?
What plasma? I don't know.
I will know if you will.
Okay, before I move on to why did they highlighted plasma is a
Let
state-
me explain
Let me explain
what plasma
what
is.
plasma is.
What is it?
Plasma is a state of matter, the fourth, which the lower form has not yet learned, and I think that the upper form has learned. For the lower form,
What lower form? Form 1, Form 2.
for the form 1, form 2, and form 3s, plasma is a state of matter where gas is ionized, or in other words, heated till the point that it is ionized, and just simply plasma is like light, but it's not light, where it can touch and it can confront each other.
Huh? I have no idea what you're talking about.
It can just like touch.
Touch what?
No, it cannot be. It can be felt, but it.
But, not but lah, but.
Let's just say it is like light, but when you
But
when you shine a light at each other, they will not
they will not.
interact. But with plasma, they will interact. Now, the reason why Dr. Aisho Lazuki highlighted plasma is because the universe comprises of 99.9% of plasma, and the other 0.1% is mainly of atoms, like other atoms like solid, liquid, and gas. Okay, thus moving on to my first point, why the universe is so interesting. Galaxies. Okay, to me galaxies.
Stop saying okay. Too many okays.
Galaxies to me are a very interesting subject. Why? First of all, galaxies has 3 types. The first one, spiral galaxies. As you can see, why it is called spiral is because the outer rim of the spiral galaxy is swirling towards the inner part of the galaxy, or in more accurate subjects.
Accurate. Hey, there's a T at the end of it.
Accurate.
Right.
In more accurate terms, the nuclear bulge, where the nuclear bulge consists of all the stars, and where the disk of younger stars and the halo, which is a loose formation around the galaxy, where there are also dust particles contained in them. Other than spiral galaxies, there are also elliptical galaxies. As you can see, it is rather plain, as it has no axis of rotation, which means that it is quite static. But it still has a shape. And the last one, which is the least interesting one to me, is the irregular galaxy. As you can see, it has no shape at all, and it's very irregular. Now, moving on to my second point, why the universe is so interesting.
It's so interesting.
Before that, quick fact. Originally, Nebula was a name to to galaxies, as in which the Andromeda galaxy, the closest galaxy to our galaxy, the Milky Way, is originally named the Andromeda Nebula and
Andromeda.
And before the true nature of the galaxies was known in the early 20th century,
20th.
century, the galaxies were known as nebulas. My second point, black holes. Now this does not refer to any lewd meaning. Okay. This is what we call a black hole. Now, a black hole is a region of time where it has a strong gravitational pull, where even light itself cannot escape from the black hole. And in the black hole, and as you can see, it even distorts light. As you can see, it even distorts light because of the strong gravitational pull within the black hole. And as you can see here, this is what we call the event horizon, and this is where most events where things are pulled into where this is the last resort for the thing to get out and escape the gravitational pull of the black hole before it's too late and it is knocked into the black abyss of the black hole. And for your information, black holes can be reduced to can perish due to Hawking radiation. Now, does anyone in this room know what is Hawking radiation?
No, what is that?
For your information, Hawking radiation is a radiation emitted by the event horizon itself in the black hole, and it emits Hawking Hawking radiation because of due to how many the black hole devours planets or other subjects. And
Repeat the sentence. How many what devour?
How many planets
Right.
or other items devoured by the black hole. And if the black hole is subjected enough to Hawking radiation, the black hole will suffer from it and will decrease its size. And lastly, to my third point, the mysteries of the universe. Okay. In the universe, there are tons of what we don't know. There could be, and if we have enough time to explore the universe, we might find alien planets, we might find alien life forms, or you might even find the mystery behind the dark matter. Now, before I move on, does anyone know what is dark matter?
It's dark.
Yes, it is dark. Okay. There are dark matter and
Hamizan? Someone said Hamizan?
okay. Dark matter is something that is, well, a mystery to us. As you can see in galaxies, you can see there are dark spaces between stars. Now this is what we call dark matter. And what moves this dark matter is called dark energy. And during the creation of the Big Bang, 63% of the universe was comprised of dark matter, and others 12% atoms, 15% photons, and 10% neutrinos. And today, dark energy dominates other other energies. And as you can see, dark energy is 72% of the universe, dark matter 23%, and atoms 4.6%. And as you can see, this is how small how small we are in the universe. And there are also the hypothesis of the multiverse, where the universe has different versions and versions of the universe itself. And there are also the mystery of what the universe is shaped like. Some thought it might be spherical, some thought it might be bent, or some thought it might be just flat, plain flat.
What do you think?
But lastly, in the end, we're all just a man in a planet called Earth.
On!
On a planet called Earth. In a galaxy called Milky Way. In the wide unknown universe. That is all for me. Thank you.